Hello, grade 8 learners! Today is another opportunity for you to enjoy learning mathematics. I'm Sir Oliver, your Mathematics 8 teacher from Ciudad Nueva de Naik National High School, and I'm here to guide you in today's lesson. Are you ready? So bring out your pen and your self-learning module. Together, let us explore the concept of proving statements on congruent triangles. Congruence of triangles is studied because of its many applications in the real world. By definition, you need 6 pairs of corresponding parts between two triangles to establish their congruence. Congruence for triangles are reflexive, symmetric, and transitive. Get a piece of paper and cut a rectangle. Then, cut along its diagonal to form two triangles. Suppose you place one triangle on top of the other. Is one larger or smaller than the other? Do they appear as one? What must be true about the parts of the two triangles? So I'm going to place one triangle on the top of the other. Thus, I must say that the two triangles are congruent because they appear as one. Build your understanding. Let us investigate the two triangular pieces cut. The triangles named triangle HAT and triangle LEY. If triangle HAT is placed on the top of triangle LEY, the two triangles coincide and match exactly. The corresponding parts of the two triangles are matched as follows. So now we are going to list all the vertices, all the angles, and all the sides of the given two triangles which are congruent and corresponds with one another. And we are going to use the symbol this to denote correspondence and is read as corresponds to. So let's start with the vertices. So we have here vertex H or point H. So we will write it as H to denote a vertex. That corresponds to point L. Another point A corresponds to point E. And then point T corresponds to point Y. Then for the angles, so we have here angle H corresponds to angle L. Then we have angle A corresponds to angle E. And we have angle T corresponds to angle Y. And for the sides, we have segment HA or AH. So we have here segment HA corresponds to segment LE. We have segment AT corresponds to segment EY. And last but not the least, we have segment HT or TH corresponds to segment YL. Notice that the matching parts of the triangles fit exactly. The matching parts are in equal measure. Therefore, the corresponding parts of the triangles are congruent, and you can say that the two triangles are congruent. Two triangles are congruent if and only if their corresponding sides and angles are congruent. So let's have triangle NIT and triangle MUD. So as you have observed in the two triangles above, you can identify the congruent sides or angles by using special markings. So we have special markings for sides and we have special markings for angles. So can you list all the corresponding angles and sides which are congruent with the given illustration? So write your answer on a piece of paper. Would you able to list all the angles and sides which are congruent with the given illustration? Very good! Let us see if you got it all correctly. And here are the answers. Corresponding angles which are congruent are: angle I is congruent with angle U, angle N is congruent with angle M, angle T is congruent with angle D. Corresponding sides which are congruent are: segment IN is congruent with segment UM, segment NT is congruent with segment MD, and segment TI is congruent with segment DU. To indicate the congruence of the two triangles, you can use the symbol this. For congruence, this implies that the corresponding parts are equal and similar, right? Triangle IND is congruent with triangle UMD. When naming congruent triangles, you must write the corresponding vertices in the correct order. That is called CPCTC, or corresponding parts of congruent triangles are congruent. Since congruence of segments and angles satisfy the reflexive, symmetric, and transitive property, then so thus congruence of triangles. Thus, congruence of triangles satisfy the following properties. First property, reflexive. Triangle EDS is congruent with triangle EDS. Second property, symmetric. If triangle MAR is congruent with triangle KLO, then triangle KLO is congruent with triangle MAR. Third property, transitive. If triangle SON is congruent with triangle DTA and triangle DTA is congruent with triangle CEL, then triangle SON is congruent with triangle CEL. We have other properties of equality. Addition property. If x equals to y, then x plus z equals y plus z. Subtraction property. If x equals y, then x minus z equals y minus z. Multiplication property. If x equals y, then xz equals yz. Substitution property. If x equals y, then x and y may be substituted for each other in any equation. And last, but not the least, distributive property. X times the quantity y plus z equals to xy plus yz. Grade 8 learners, how much do you know? Apply the properties of triangle congruence to answer this activity. Ready? Write your answer on a piece of paper. Use the illustration given to answer the activity. For letter A, you need to name the required side or angle. So you need to answer items 1 to 6. For letter B, you need to identify the properties of congruence for triangles for items 7 to 10. Time is up! Here are the answers. Kindly check your work. Let us explore your understanding. We will state and illustrate the SAS, the ASA, and the SSS congruence postulate and SAA congruence theorem. We will prove that the two triangles are congruent using two-column proof. So, let us begin. Explore your understanding. 1. Side or SSS postulate. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Here's a very simple example showing how the SSS postulate or the side postulate is used in proving triangle congruence. So let's have example 1. So of course, we have here our given square LOVE or square love and its diagonal segment LV. So as you have seen here, we have here our square LOVE and then diagonal is being drawn. So we have here segment LV and then as you have noticed, it is divided into two triangles. We are going to prove these two triangles. We have triangle LEV. Is it congruent with triangle LOV? So for our solution, so in proving triangle congruence, we are going to make a two-column proof. So for the first column, you are going to write all your statements. And then for the second column, you are going to write all your reasons. And then in the end of your two-column proof, you need to prove whether the two triangles are congruent by applying the postulate. Okay, so we have here the first statement. So always in writing a statement, so it will be started with the given. And our given is square LOVE and then segment LV is diagonal. And then our reason is given. And then for our second statement, we have segment LE. So we have here segment LE is congruent with segment OV. So segment LE, so we can put markings. So segment LE is congruent with segment OV because we are pertaining to square and we all know that square has four equal sides. So same with segment LO is congruent with segment EV. So LO is congruent with segment EV. And then our reason for that is definition of square. Because square has four equal sides. So meaning to say that all the segments given are congruent with one another. And then for number 3, we have here the diagonal LV. So segment LV is congruent with segment LV. So reason is reflexive property. Because these two triangles share the same side, which is LV. So when we separate, when we draw it separately, so they have a common side, which is LV, and then it is congruent. So therefore, for our last statement, triangle LEV is congruent with triangle LOV, and then our reason is SSS postulate, supported by our statement 2 and 3. So that is for our first example. So we write statements proving that the two given triangles are congruent by applying the side-side-side postulate. Try this. Given rhombus STAY and its diagonal segment TY, prove triangle TSY is congruent with triangle TAY. And here's the answer. Kindly check your work. Two, side angle side or SAS postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Example 2. So we have here our given triangle BOW and triangle BAT. So let us refer with the given illustration here. So this is triangle BOW that we need to prove that it is congruent with triangle BAT. Again, BOW and triangle BAT. And then the other given is that B, so we have here point B, is the midpoint of segment OA and segment TW. So we have here OA and then the midpoint is B. So meaning to say that it divides the segment into two congruent segments, which is OB and AB, since B is the midpoint. So likewise with TW, so if B is the midpoint, so meaning to say that the two segments are congruent, so which is TB and BW. We are going to prove that the two given triangles are congruent, and for our solution, we're going to use the two-column proof. So for the first column, we have here the statements, and for the second column, we have here the reasons. So the first statement is the given. So wherein our given is B is the midpoint of segment OA and segment TW. So our reason is, of course, it is given. And then for our second statement, since our first statement is that B is the midpoint of segment OA and segment TW, so we can write another statement out of that, that is segment TB is congruent with segment BW. So let us put a marking in our illustration. So TB is congruent with BW. And then, segment OB is congruent with segment BA or AB. So OB is congruent with segment BA. So of course, our reason is definition of midpoint. So that is definition of midpoint. So it divides the segment. For example, we have here OA. So it divides the segment into two equal parts if we have drawn a midpoint. So from the word itself, midpoint, so meaning to say that it is a middle point between the two, or between the given 2 points. So meaning to say that OB is congruent with AB. And then for our statement number 3, so we can say that angle OBW and angle ABT are vertical angles. So we have here OBW and ABT. So they are vertical angles. So of course, our reason is definition of vertical angles. And then for statement number 4, since angle OBW and angle ABT are vertical angles, so we can make a statement that they are congruent. So angle OBW is congruent with angle ABT. Ang ating reason is vertical angles are congruent. And for our last statement, we can say that triangle BOW is congruent with triangle BAT. So our reason is by applying the SAS postulate. So we have here two sides which are congruent. So we have here BW and BT, BO and BA, and then we have here an included angle that is congruent. So we have here OBW and ABT. So therefore, it is proven that the two triangles are congruent by applying the SAS postulate supported by statements 2 and 4. Try to answer this. Given segment TJ and segment RN bisect each other at L, prove triangle JRL is congruent with triangle TNL. Time is up! I hope that you get the answers correctly. Three, angle side angle or ASA postulate. If two angles and included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. For our example number 3, so we have here our given segment BA is congruent with segment C. So let us refer with our illustration for us to be able to write our proof. So let us put a marking. So BA is congruent to CE. So meaning to say that they have the same measurement. So itong BA and CE, so they are congruent with one another. BA, so this is the symbol for perpendicular. to segment AE. So BA is perpendicular to segment AE. So meaning to say that if they are perpendicular with one another, it forms a right angle. So meaning to say that the measurement is exactly 90 degrees. And then same with segment CE is perpendicular with segment AE. So meaning to say that it also forms a right angle. And then another given is D is the midpoint of AE. So D is the midpoint of AE. So meaning to say that it divides the given segment into two equal segments or two equal parts. So we can say that AD is congruent with AE since D is the midpoint of this given segment. So let us put marking here. Then we are going to prove BAD, triangle BAD. So we have here triangle BAD is congruent with triangle CED. Of course, to formally say that the two given triangles are congruent, of course, we need to show our solution by writing a two-column proof. So for the first column, we have here statements, and for the second column, we have here the reasons. So let's start with the first statement. Segment BA is congruent with segment CE. And then segment BA is perpendicular with segment AE. So that is our given. And then for number 2, so since we say that segment BA is perpendicular with segment AE, so we can say that angle A is a right angle. And then reason, definition of perpendicular. Again, perpendicular lines form a right angle. So, therefore, angle A is a right angle based on the first statement that BA is perpendicular with segment AE. So, it forms a right angle which is angle A. Segment CE is perpendicular with segment AE. And that is also our given. And then from this statement, so we can make statement number 4 that angle E is a right angle. So same with the reason for statements 1 and 2. So our reason is definition of perpendicular. For number 5, so we can make use of statements 2 and 4 since they are both right angles. So we can say that angle A is congruent with angle E. Reason, any two right angles are congruent. Okay, let us continue. So for our statement number 6, so we have here another given which is D is the midpoint of segment AE. Of course, our reason is given. And then From that statement, so we will be having another statement which is segment AD is congruent with segment ED. So our given is D is the midpoint, so meaning to say that AD is congruent with DE since D is the midpoint. Of course, our reason is definition of midpoint. And then for our last statement, now we can prove that triangle BAD is congruent with triangle CED based on our given statements from 1 to 7. And then our reason is A as a postulate, or the angle side angle postulate. Try to answer this. Given segment LI is perpendicular with segment IO. Segment DO is perpendicular with segment IO and is the midpoint of segment IO. Proof: triangle LIN is congruent with triangle DON. Quite difficult, grade 8 learners? But I hope you get the same answer. Very good. And last but not the least, we have for side angle or SAA postulate. If two angles of a triangle and a side opposite one of its angles are congruent to two angles and a side opposite one of the angles of another triangle, then the two triangles are congruent. For our last example, example 4, given segment AC is congruent with DB. Again, let us refer with the given illustration and let us put a marking. So it says in the given that AC is congruent with DB and another that AC is parallel with DB. So when you say parallel lines, so these are lines that do not intersect. So no matter how far you extended the given line, so AC is parallel with DB. And then we are going to prove that the two given triangles are congruent, which are ACE and DBE. So let's write the solution. So our proof, so we have here two columns. So for the first column, we need to write all the statements. And for the second column, we need to write all the reasons. Again, let us start with the given. Segment AC is congruent with segment DB. Another, segment AC is parallel with segment DB. Again, our reason is given. For number 2, we have angle C is congruent with angle B. So we have here angle C is congruent with angle B. Our reason, since segment AC is parallel with BD, so when we extend the line and then this line BC is our transversal. So when we say transversal, it is a line that intersects the parallel lines. So let us extend the line. So for example, we are going to extend the line. Okay, so this line CB is the transversal because it passes through the two lines that are parallel with one another. So that's why for our statement 2, angle C and angle B are parallel with one another. So that is under angle pairs and relationships. So the two angles are said to be alternate interior angles. So that is alternate interior angles. So our reason would be parallel, alternate interior angles postulate. Or you can say that alternate interior angles are congruent. So that's it. So that is parallel lines cut by a transversal line. So angle pairs and relationship. So that's why we say that angle C is congruent with angle B. Then for number 3, we have angle AEC is congruent with angle DEB. Again, angle AEC, so let us put markings, and then is congruent with angle DEB, so DEB. So they are vertical angles, and vertical angles are said to be congruent. So therefore, our reason is that. So what is that? Vertical angles are congruent. When you say that is vertical angle theorem. So meaning to say that the two angles that are vertical with one another is said to be congruent. And then for our last statement, so we can say now that triangle ACE is congruent with triangle DBE. Our reason is, for our statement number 4, you have SAA congruence postulate. So that's it for our last example. So I hope that you'll learn from our 4 examples given to prove that the two triangles are congruent by applying the different postulates that we have. And for your last activity, try to answer this. Given, angle N is congruent with angle T. A is the midpoint of segment ME. Proof triangle MAN is congruent with triangle EAT. Time is up, and here are the answers. Grade 8 learners, did you get it all correctly? Excellent! Before we formally end our lesson, I am giving you activities to enhance what you have learned in our today's discussion. Please turn your module on What I Can Do part. That's it for today, grade 8 learners. Again, this is Sir Oliver Ortiz, your Mathematics 8 teacher from Ciudad Nueva de Naig National High School, saying 2 important things that you need to remember in learning mathematics: focus and practice. See you in our next episode. Bye!